we have learned how to find the composition of two functions. But the question probably burning within you at this moment is, well, what's that used for? In section 3.2.3, we will examine a couple of applications of compositions. Let's look at example 7. On Black Friday, a store is offering 30% off store-wide all day. An early bird special allows an extra 50% off the discounted price before 7 a.m. You are purchasing a computer that retails for $1,000. If you purchase the computer before 7 a.m., what is the purchase price before tax? So, are you a Black Friday shopper? Do you get up early and fight the crowds and feed on the energy and the excitement? Or are you one of those that stays home and shops online? Maybe you're someone that works retail and you have to deal with the public on Black Friday. Well, the next time Black Friday rolls around, I hope you think about algebra class. We're going to solve this example with a composition. Now, it says that the store-wide sale is 30% off all day. 30% off all day. Now, there's an early bird special that allows an extra 50% off the discounted price if you go in early before 7 a.m. You decide to purchase a computer that retails normally for $1,000, but you're going to get up early, you're going to go shopping so you can obtain not only the 30% off store-wide all day, but also the early bird special of 50% off. Now, you shoppers out there, what's your first instinct? How much is the computer going to cost? 30% off store-wide all day and 50% off the discounted price. You might be thinking that means 80% off, right? But actually, that is not correct. So let's talk about how we're going to determine the price of this computer. So we've got a store-wide sale of 30% off all day. Now, if we have 30% off, that means, I'm going to try and make this real simple here, that means we're paying 70% of the original price, right? 30% off means we're paying 70% of the original price. So let's say our Black Friday function, we'll call it B of X for Black Friday, where X is the price of some item, is going to be 0.7x, or 70% of X. So in this case, X is the original price, and B of X represents the Black Friday discount price. Okay, so if I get there at 11 a.m. and I buy this computer for $1,000, I'm only going to have to pay $700. Okay, now I'm going to go in not at 11, but before 7, so I'm going to get the early bird special. Let's call this E of X. Okay, now if I'm going to get an additional 50% off, that means I'm going to pay 50% of whatever that discounted price is. Okay, so E of X represents the early bird additional discount. What I need to do is apply these two functions in a row. We need to apply the early bird special to the Black Friday special. We're going to find E of B of X. So B of X is 0.7x. I'm going to now plug that into the argument for the other function to get 0.5 times 0.7x. And what do we end up with? We end up with 0.35x. So if our original price was $1,000 and we apply both of these discounts, we're going to pay 0.35 or 35% of 1,000. So we will pay $350 for that computer. Now, if you're really engaging in a Black Friday sale, you're probably not going to write a function to model this. So let me take you through that with the calculator. So the original price is $1,000, and you're going to pay 70% of that price. That's the store-wide discount. So the discounted amount is $700. But then, getting there early, I only have to pay 50% of that already discounted price, which means I pay $350. So with the calculator, I just evaluated both discounts successively, which is what we're doing with the composition. So we don't sum the two discounts. We don't do 30% plus 50% to get 80% off, in which case we would have paid $200 for the computer. We multiply those two discounts according to the composition. Another place you might come into contact with the composition is maybe in a science class, maybe a science lab where you're converting Celsius to Fahrenheit to Kelvin. That's what example 8 deals with. The function C of f equals 5/9 times f minus 32 relates Celsius temperatures and Fahrenheit temperatures. The function K of C equals C plus 273.15 relates Celsius temperatures and Kelvin temperatures. So Fahrenheit is the temperature scale that we use in our country, but if you go overseas to Europe, for example, they use the Celsius scale for their temperatures. However, if I am measuring maybe the temperature of an asteroid in deep space, in that case, I'm going to use the Kelvin temperature scale. So we have 3 different temperature scales that we are examining here. Our problem is to convert 98 degrees to Kelvin. Now, you can do this with the composition, but remember, a composition is really just evaluating 2 functions in a row. So we need to convert 98 degrees Fahrenheit to Kelvin. So what we're going to do first, we have a Fahrenheit temperature. We're going to first convert that to Celsius, and then we'll take that Celsius value and convert it to Kelvin. So notice again, we're just evaluating 2 functions in a row. So we're going to find C of 98 degrees. So I'm going to plug 98 in for F. And let's evaluate what's in parentheses first. And let's evaluate 5/9 times 66. I'm going to convert that back to a fraction to keep it exact, 110 over 3. So I'm going to observe this is about 37 degrees. I'm going to leave it as 110 over 3. Okay, so I'll make myself a note. This is about, and if we did that to the nearest hundredth, 36.67. 36.67 degrees Celsius. So we started with 98 degrees Fahrenheit. That's a really hot July day in Amarillo. That would be measured at 36.67 degrees Celsius. Okay, but we're trying to get to Kelvin. So our next conversion formula goes from Celsius to Kelvin. So let's find K of 110 over 3. So we have 110 over 3, and the reason I'm using 110 over 3 is because I'm waiting to the very end of the problem to round. If I round here and I round here, I might get a little bit of rounding error, so I'm just being careful about that. If you wanted to use the 36.67, it probably wouldn't make that big of a difference in this problem. So 110 divided by 3 plus 273.15 rounded to the nearest hundredth, that is 2 decimal places, is 309.82 degrees Kelvin. So it's a much wider scale than either Fahrenheit or Celsius. So another way to think about that as far as composition goes, first we evaluated C and then we evaluated K. So what we're doing here is a composition. We evaluated this function first. We had an input. The output was 110 over 3. Then we plugged it into this function second, and we were able to obtain 309.82 degrees. So the application of compositions comes when we're evaluating 2 successive functions. We plug a number into the first function and get an output, and then we take that output and turn around and immediately plug it into a second function to get the final output. All right, that completes section 3.2.